Hi everyone, are you able to hear me clearly? Hi Pavan, please feel free to introduce yourself as others are joining. Alright, alright, hi. So welcome to the Big Data Analytics session. It's a 2 hour session, alright? So we will devote this session for understanding of the big data, and then we will go into the details of various big data use cases. All right. Second half is mostly going to be big data use cases. All right. So those of you who have been part of my previous sessions on Hadoop might find it a little repetitive. All right. So this is the first session on big data analytics. So please feel free to introduce yourself. Yes, Rama Reddy, you have a question? Please type the question into the window. It's a 2 hour session, please note. All right, all right. So it's a it's a first session with 2 hours duration. In the first half, we will cover understanding of big data. Then we'll take a 5 minutes break. And in the second half, we will cover the big data use cases. The session is being recorded, and this recording and the presentation will be shared with all of you. All right. So let me start another form of recording in case this GoToWebinar does not work. All right, let me just start the screen recording. All right, good. So please feel free to introduce yourself as you are joining the class. We have Deepak here, and Deepak is an Oracle DBA. Welcome, Deepak. Sai Ram's question is wanted to know. Let me copy paste these questions into the notepad so that we all can see it. And yeah, and once you can see it, it'll be easier for you to grasp the context. Okay, so that's a question from Sairam. All right, BDA1. So this is the question from Sairam. Sairam is asking, wanted to know whether this training would be helpful for .NET application programmer. of 8 to programmers of 8.5 years to switch the job. All right. So, are you? It depends on. Uh, are you a web developer or are you a thick client application developer? Okay. All right. All right. In C sharp and others. Yes. So, most of the big data analytics uh, job is generally to understand how to analyze the data and how to present the data. Okay, and also as part of the analysis there is another section called prediction. Okay, if any of these three lines interest you, then big data analytics will be helpful for you. Generally in big data analytics you do not program in Java, generally, but you might have to code in R or similar kind of analytics language like Hive or Pig. All right. All right, let me take another question before we start. Here is a question from Deepak. So, can you tell me what is the role of Oracle DBA? So, the role of Oracle DBA, it because you had been writing SQL, and so you have a fair amount of idea about presenting data. So, this training might be helpful for you. Okay. So this training is generally great for those people who have been into analytics and want to step ahead into big data analytics, or somebody having an interest in big data analytics. This course assumes that you have a basic understanding of what is a database and how does it work, and you have a basic understanding of statistics, and that's how this course is structured. So we have Pawan. Pawan is a mainframe developer. Welcome, Pawan. All right. So if you are looking for a developer's course, I would actually recommend to you big data and Hadoop kind of course. But do not worry. This today's session is open for all. This today's session is kind of a common. There is only slight differences from the big data and Hadoop session. So do not worry. Attend today's session. You will get a fair amount of idea about the Hadoop ecosystem and the big data ecosystem in general, and then you can take a call at later point of time. All right. So we will try to keep this session more interactive by trying to answer your questions. So Deepu's question is, do you have something in Spark training? If you go to our website called knowbigdata.com, there you will see something called Big Data and Spark. There we cover all the things related to the Spark. Deepak is saying that I want to go into administration part. Right now we do not have an administration part, but definitely there are other places where they provide a great administration training. All right, great. All right, yes, great. So we have a great session. Let's jump in. There are two more questions to answer. One is from Pawan. Pawan is saying, can you throw some light on how a mainframe developer can switch to big data? Okay, so so if you are from mainframe background, I'm assuming that you have a good idea about a programming language such as COBOL. and you have an idea about relational databases. So after you have attended the big data and Hadoop developer course, you will be ready to get into the big data developer role. All right. Just that you'll have to do a lot of hands-on and you'll have to work along. Okay. There's a question from, all right. All right. We have a question from Madan. I'm just pasting the questions here so that we all can see. Madan is saying, hi, this is Madan. I'm a Java developer. What is the difference between big data and Hadoop? Is it mandatory to learn Hadoop to get into analytics? The answer is no. Big data analytics course will teach you everything related to big data and everything related to Hadoop that is required only for analytics, not for the development or building the components part. Okay. All right. Now we have a question from Sahab, Sahib Saqib. I'm a SaaS developer with 7 years of experience. I want to switch to analytics domain. Is it a good decision? Yes, of course. Yes, because if you are a SaaS developer, okay, then you have a fair amount of idea about SaaS already. And if you want to do analytics for some time, it will be fairly easy for you, just that you'll have to review a bit of statistics and review a bit of analytics. So the, and I think it's a good idea for you to move to analytics for some time so that you will have a complete picture of development as well as analytics in the analytics domain. All right. Vinayak's question is, why can't I see the other attendees? Actually, GoToWebinar does not allow other attendees. That's why I had to put it in the notepad. We have a question from Mohammed. Mohammed's question is, he has 5 years of experience in supply chain and he is new to the big data domain. So, for that matter, do not worry, Rizwan. There are lots of people who are new to big data. It's fairly, comparatively, a newer technology. So, will you be providing internship to get hands-on experience? Uh, we provide the hands-on project only to the candidates who really perform great in our trainings. So we have Pranav. Pranav is looking forward to pursue masters in computer science. Great, great to know you, Pranav. Vineet is from Informatica. How is big data different? You will soon find out, Vineet. No worries. Okay. I mean, the whole objective of this session is about about uh, understanding what is so different about big data domain. All right. Pranav's follow-up question is, please tell me what are the things that would be helpful for you. So this session is definitely helpful for you, Pranav. So this session is going to take you through the different aspects of big data and why are we talking about it now, and what are the things that have changed and how does the software changes as the data grows. All right. Because as the data grows, the software of course changes. All right. Now, Sairam's question is, um, how is Hadoop developer? How different is Hadoop developer from data analytics developer? Do you mean big data analytics, right? So in Hadoop developer, you might have to code, but in case of analyst, if you are a data analyst, then you might have to analyze data, understand the correlations, and you should have the ability to present data. All right. What is the future scope of Hadoop since Spark is taking its position? So that's Ravi Kiran's question. So that's a good question actually. So Spark is not replacing Hadoop. Spark is only complementing it. All right, as you will soon find out, Spark is great for really fast moving data, but when it comes to hundreds of petabytes of data, Spark still is similar to what MapReduce is. Moreover, Hadoop is a big ecosystem. Spark is just helping in the computing problem. All right. So Hadoop provides a lot of component, including storage, including other other things such as Zookeeper, and there are many services which Hadoop provides. Spark is competing with the compute engine. All right. Hi, Aisha. We have a question from Aisha. Question is, how is it related to big data? In terms of security, how is it related in big data analytics? So, in terms of security, data security, generally, big data analytics team is not generally too keen on the security, because security is generally taken care by either ops, or it is generally taken care of by the developers. The analytics teams is more focused on figuring out the correlation amongst the data and representing the data, right? So Madan's question is, what is the prerequisites needed to attend this session? To attend this session, you have just basic idea about the databases, or how do we generally organize data, and a little bit knowledge about statistics you should be aware of. For example, what is standard deviation? If you can answer that question, you should attend this today's session. All right. Now, yes, Vinesh, the webinar is recorded and will be shared with everybody. All right, good. So we have a question from Pranav. Pranav's question is, business how are analytics and data analytics are related to each other? Both are almost the same thing, because you cannot have analytics without the data, right? So generally, the business analytics is all about analyzing the data. Does data analytics have a role in MIS? Of course. MIS is just another name of presenting the various kinds of information in various reports. Okay. So Chinmay's question is, how is big data related in revenue assurance and fraud management? You will get to see it soon. All right. Great set of questions. So Saib's question is, I have knowledge of Java but not Ruby or R. Is it important to learn Ruby or R? Not really for this course, but as we go through this analytics course, since R is important, we will give you a basic tutorial on R. Okay, one of the sessions will cover R. All right, let's start the session now. All right, great set of questions, and I love answering everybody's question, and I'll try my best to answer every question. In case I miss the answering the question, you can come to our website and leave your question in the forums, and I'll try to answer it there. All right, so let's start. So first of all, welcome to Big Data. We take pride in informing that we our instructors are expert in their domains. We provide something called Cloud Labs. We call it CloudX Labs now. Okay. So you can have a look at our CloudX Lab. So we basically provide all the infrastructure, all the services, along with the gamified training in our CloudX Lab. We provide lifetime access to the LMS. LMS contains presentations, recordings, assignments, and quizzes. Like this session, every session contains recording and the assignment and the quizzes. All right. So with respect to the real life project, we provide the real life project to the candidates who finish our assignment and quizzes really well. And generally, there is only one or two candidates out of a batch of 2025 for the real life project. The course completion certificate we provide if you finish our project. There is one project which is as part of our course and one project as part of the. All right. Now, we provide a 24 by 7 email support and we have a group for alumni. All right. So great. So about myself, I did my graduation 2002, which is quite 13 years ago, from IIT Roorkee, and then I joined a company called DE Shaw, where we built big data systems and analyzed humongous data before even the term was coined. And we were probably one of those early companies who were handling terabytes of data and churning few terabytes of data every day. So that was DE Shaw. After that, I started a company called Tbits Global, where we built a document management system. Afterwards, I joined a company called InMobi, where we built a recommender that churned around 200 terabytes of data. Afterwards, I joined Amazon, where we built high throughput systems for Amazon.com using an in-house NoSQL. All right, the systems which we built at Amazon were similar to the stream processing systems which you see outside. And in 2014, last year, we started No Big Data with the sole aim of training people into big data technologies because an experiment in big data technologies. So right now we provide solutions, training, as well as we have a couple of products which people are using, including our CloudX Lab. So that's about No Big Data. So right now we are also helping Dell in their order analytics, real time order analytics. All right, so Vinayak, that answers your question. Great, great. Nice to, it was very timely question from him. It was about my background. All right, so let's understand what does this course offer you. Today we are uh, going to go through big data and its use cases, and afterwards, in the second session, we will talk about the various architectures of big data, and then we will understand the basics of what is HDFS and yarn quickly, and afterwards in the session number 3, MapReduce plus NoSQL will be covered, the overview of both of them. So you don't have to do actual the programming, but you will get an idea about what does both of these things do. Then in the fourth session, we will talk about HBase and a little bit about MongoDB. So the idea is within first 5 sessions, you will get an overview of the complete technologies, what are the various different kind of technologies in big data. So by the session 5 you should get a fair amount of idea about various available products in big data and when to use which one. All right, now from the session 6 we will dive into the statistics and statistical inference, so that you can, given a data, you should be able to, even if the small data or big data, statistics kind of remain same. It's just the way we compute the statistics changes. If it's a small data, let's say there are four numbers, okay, you can do the summation using a simple without using a calculator. If you have 20 numbers, you might have to use a calculator to sum it up. If you have bigger than that, you might choose an Excel sheet. But if you have bigger data than few hundred rows, then you might go for a database. And then if you have bigger than a million rows, then the database may not be helpful, right? And as the data grows, your choice of tools changes. It changes from simple pen and paper to the database as the data grow. And after your number of records grow out of something like 100,000 records, your database will, not 100,000, like 10 million records. After the data grows beyond 10 million records, your MySQL, Oracle, or MS SQL cannot help. So computing the summation of 10 million rows will be a big challenge even for a normal database. All right. So I'm just taking the summation, the sum, A plus B kind of a problem. Even so, as the data grows, your choice of tool is going to change. That's why this course actually covers the entire stack. So we will cover statistics, like what are the various ways of computing the statistical inference, how to decide whether a hypothesis is wrong or right. So that we will cover in statistics and statistical inference. Afterwards, we will dive deep into understanding simple analytics, and we will try to do a simple analytics using a bit of SQL and using a tool called BIRT. So if you have a small data of something like 100,000 rows, how would you present it using BERT and SQL? After that, if your processing goes complex and visualization goes complex, you will have to choose, you'll have to shift to R or similar technologies so that you can visualize data and present data. All right. And as we go forward, we will understand what are the various difficulties people face in analyzing data, and we will try to do that using R. Afterwards, so one part of the whole training is analytics, other part of and big data, first is statistics, big data, big data technologies, and then uh, technologies like R and BERT. And then the most interesting part of the course is the real time analytics. We will talk about real time analytics, which have not been mentioned here right now. So we will dive deep into the details. All right. So everything which needs to be done for big data and analytics. Big data means the entire technical scale, technology landscape, and analytics comprises of statistics, SQL, R, and and even a little bit of W we will talk about. Okay, and the presentation. So that's about the course curriculum. We will also get into understanding these two new tools, MLlib and Spark R, and understand where do they come into use, and what is so great about them, and when to use which one. So this is a really a big course, and it is something which is very unique to us, because we realized that there is a big gap in the industry which none of the colleges, including MBA colleges, none of them are filling it. Okay, they all talk about big data analytics, but they all end up training Hadoop. All right, but this course is going to be probably the cutting edge one, because the Spark R, for example, has been released around 8 months back. Not 8 months back, 3 months back. In April or May, it came into production. So our whole idea is we can see that Spark R is going to be the next big thing in big data analytics. So we are focusing on that. All right. So all of these tools, although Mahat is going to be covered very small, but we are going to focus more on MLlib because MLlib has mainly replaced Mahat. Okay. So we have been fairly choosy about technologies, and we will also try to improvise on the size of the content based on their importance. So the overall idea, the overall purpose of this course is the people who aspire to get into analytics, the people who are from management background and have not studied the analytics. They have been they have become manager by the because of the role, but have not gone through the analytics. This course will try to focus on them. Specifically, if you look at the statistics and statistical inference, that's going to be a little bit tough ride. All right. So, so the course has been designed for those who aspire to gain expertise in big data analytics. The course will take 36 hours, and that's why it's a little costlier. All right. So 36 hours. These 12 classes are with respect to 3 hours each, which means 36 hours. And for 2 hours, this since this weekdays courses are going to be 2 hours, therefore it will be 18 days, 18 working days. All right. So this is about the big data analytics course. So here the most important part is how to do analytics using the latest tools. How do you do analytics on huge data or small data? So those are the things which we will teach as we go forward. All right, both analytics and visualization, because visualization is part of analytics. All right. So in today's session, these are the various topics we will be covering. So those who have been part of my uh, earlier sessions, they may find some of it, most of it actually repetitive. All right. So if you have attended my big data and Hadoop course in the first session, today's session might be similar to that one. Okay. All right. So let's begin with understanding the distributed and parallel computing. So why are we talking about this? You will understand it soon, because when we analyze bigger data, I'll just try to stop the suspense. So when we analyze big data, we cannot do it on a single machine, and therefore we would require multiple computers or multiple CPUs. Okay, so we'll first talk about distributed versus computing, because that's the heart of big data and big data analytics. Now, when you group group various computers over a network, and these computers interact with each other to solve a common goal, we call it a distributed system. And a parallel system is one in which there are multiple CPUs, multiple processors, but it's a single system having a shared memory. So that is the common thing between distributed and parallel. Also, please note that in both the cases, in distributed versus parallel, we distribute our logic to multiple computers. Let's say we are trying to execute a query like an SQL query. Rather than it be executed only on one machine, in case of distributed environment, that query will be executed on multiple computers parallelly. Similarly, in case of parallel environment, the same query will be executed parallelly on different sections of data over multiple processors. So the logic, the philosophy of distributed and parallel intersect a lot. So most of the things which are distributed in nature can also work on multiprocessors. Okay, therefore Spark, Hadoop, everybody tries to be tries to accommodate multiple processors as well as multiple machines. Okay, so that is a bit of definition. Now, second definition which we are going to discuss is what is data variety. Lots of time we will see what is the kind of data we talk about. It's structured, semi-structured, unstructured, but at the end of it, all of it is just the data. Okay, so when we know in our input data what are the fields as well as what are their data types, then we call that data as structured data. But in case we do not know their data types, but we know what are the fields in the input, then we call it semi-structured data. But in case we do not know the fields, what are the fields in our input, also we do not know what are their data types, then we call it unstructured data. So, for example, the examples of structured data is data in databases, semi-structured data is XML, and example of unstructured data is maybe the text gathered out of the program's logs. Program's logs means program keeps on writing to a file whatever error or information it incurs. All right, so that's about the data variety. Now, a quick question to all of you. What do you understand? What do you understand so far by big data? Anybody? Yes, Kailash. If you are not able to, because everybody is muted, you have to ask the question by typing. All right, Kailash? You have a question? You have raised your hand? Please ask it by typing in the questions window. All right? Anybody? What do you understand by big data? Good. Vivek's answer is data that cannot fit into one computers. Anusha says it's unstructured data. Sahib says big data that can support velocity, variety, and okay, those three V's. And Deepak says big data is a data that cannot be managed by RDBMS or SQL. Brilliant answers. Brilliant answers. Sairam says big data is large set greater than 10 millions which ordinary data applications cannot handle. Good, good, and control. All right, Karthik's point is it can support more data. Yes, Karthik and Kailash, please feel free to write your question in the questions window. Good. Pranav says the collection of data which is generated along the cloud and social networking. All right. You have raised a hand, Kailash. All right. So maybe by mistake. All right. Vinayak says, does big data require all computers to share same storage? Not always, Vinayak. You will see it as we go forward. All right. Great. Mohammed says that big data is more cost effective in long term compared to RDBMS for use. All right. Any day data cannot be viewed in your computer. That's Muralidharan's answer. Using and analyzing large amount of data for various benefits. So Aditya, I'll just quickly correct you. So big data is not a process. Big data is a term given to very huge data, huge in terms of speed or the other parts. We'll come to those parts. So big data in very simple words is data of very big size that cannot be processed or that cannot be handled using can't handle using existing tools. I'll just change it to handle. because not only we are processing but we are also storing the data. So big data that cannot be handled with usual tools, it could be of structured or unstructured. But the most important part of the definition is, for handling big data, you would require distributed architecture. For handling big data, you will require distributed architecture. So that's probably the most important aspect of big data computing. All right. So any data for storing or processing of which you require a distributed architecture by force. I mean, when you realize that, hey, you cannot handle this data with a single computer, no matter, even if we vertically scale our computer, then we say that it's a big data. All right. So here are the characteristics of data. Data could be big by virtue of three parts. Although there are many more V's to it, but we will not go into those V's. We will just stick to those three V's and we will try to describe what do we mean. And when we talk about analytics, we talk about the third angle of the data, which is variety. You will see that soon. All right. So our data could be big data meaning data that requires distributed computing. Data could be big data because of its volume. The volume is so high that you cannot store on a single machine, and then you call it big data. Or it could be the velocity, the number of requests that are coming from the user is so high that you cannot handle using a single machine. Then you call it velocity. Then, or maybe your big data is due to the structure of the data or your requirement of processing. Sometimes, even though your data is small data, but the kind of churning you want is really complex. As you will see in this session, that if you try to categorize the data, even few gigabytes of data is little too heavy on the processor. Okay, so for example, if you're trying to classify 1 gigabyte data, or say 10 gigabyte data, although it's neither fast moving nor it's too big a storage, but since you're going to churn it a lot, you're going to process it a lot, in the sense that you take a record, compare with all others in that manner. Therefore, it is too heavy on the computation. And when that kind of variety comes in, you really cannot get it done through a single computer. You would require multitude of computers parallel to solve your problem. And this is very common when we talk about analytics. All the problems of recommendation, classification, machine learning, all of those kind of problems lie in a complex domain, and therefore when we call it variety or complexity. So due to variety or the complexity, your data could become the big data, because your requirement could be complex or your data structure could be complex. So either of the ways, you might end up having multitude of computers. So these are the three reasons why data becomes big data. All right. So that's about, so volume you can think of where the way, where would Facebook be storing so much of data? Not a single computer. It will be using those distributed systems to store the data in the file systems. Similarly, think about all the requests you are sending to the Facebook every second or every milliseconds. All the users are updating their statuses and getting the updates, and there'll be millions of requests going to Facebook per second. To handle that kind of load, you definitely require a different architecture. Now, variety, when the problem involving complex data structure, okay, For example, social graphs, maps, and recommendation. In those cases, we call that by virtue of variety, our data is big data. All right, sounds good. A quick question to everybody, just to check that you are with me or you are sleeping. So, how many bytes are there in a petabyte? Quickly, anybody? Pranav, that's a terabyte, but you are in the right direction. So Vinayak is saying it's 10 to the power 13. Ravikant is saying 10 to the power 15. Yes, Pranav, that's right. 1024 terabytes. Brilliant. Brilliant. Let's move on. I think most of you have answered. Aditya is saying 2 to the power 50, 2 to the power 50 bytes. Brilliant. Keep going. Great. Great. Now, so this is just to give you an idea about how big the number is, petabyte. All right, it's quite small. If you look at the numbers, 10 to the power 15, it has hardly 4 digits, but this number is actually pretty big. Let me check that. So, all right. So is petabyte big data? Whether you want to consider 1 petabyte as storage, or whether you want to process 1 petabyte data or store it, do you think 1 petabyte is big data as per our definition? Or let me put it the other way, do you require do you require multiple systems to store and process 1 petabyte data? Anybody? Yes, quickly. Yes, petabyte is big data. That's right, Pranav. Because most of the systems singularly cannot store 1 petabyte data. You would require, even if they stored 1 petabyte data, reading 1 petabyte data requires really fast IOs. Therefore, a single machine will finish in years reading 1 petabyte data. Therefore, you will require thousands of computers to store and read 1 petabyte of data. Brilliant. Thank you, Sahib. Thank you, Karthik. All right. So this is a very typical graph, although showing its age now. So at some point in the history, it shows that the digital storage started expanding really fast, while analog storage, such as tapes and the paper and the books, did not increase that fast. Now, so that was around 2002. And the reason why the data started becoming expanding so fast is simply the devices became cheaper, faster, and smaller on one hand, while the network became faster and available everywhere. All right. So these are the two reasons why it became why the big data revolution started. While on one hand, the hardware or the devices became faster, smaller, and cheaper, so that everybody was able to produce data. Second, the the connectivity of between things and between people became very popular because of all the networking and because of all the connectivity. On top of it, when both the things were there, hardware and the connectivity, newer kinds of applications started coming in, which which facilitated distribution and creation of data. All right. So on one hand, the data started growing big, and similarly, the dynamics of big data markets also changed. You can see here in this diagram, as the data keeps on growing in variety and complexity, on one hand the data increases in complexity and variety, on other hand the data is increasing in the size, and accordingly various systems are evolving. So, for example, when the data was not that complex and was a smaller size, ERPs started. And as the data started increasing in size and complexities, we had CRMs, and you can see the CRM, the various features of CRM. And then after some time, when the things became more and more complex, there is web, and inside web there are many applications of complexity and the size. And the other applications, when the data becomes bigger, where the data is bigger and the complexity is also bigger, is in the domain of various sciences, as well as various verticals. And that's the kind of problem big data is solving, big data technologies are solving. So complexities and variety, as well as the size, when both the things are increasing or either of the things are increasing, you end up with the big data. So that's a quick view way of looking at it. Or we can just move it a little bit above here. All right, never mind. So there we are. All right, all right. Looks like my voice is breaking. Ravikant, is the voice breaking now? Let me mute myself and come back again. All right, I'm extremely sorry. So I have been on mute whole time as I was explaining whole thing. All right, this was extremely stupid on my part. All right, so let me repeat what I was saying. Okay, so all right. Sorry for being on the mute and not looking at the questions window. All right, let me. Anyway, it gave me a better chance to be crisp and concise. So we were talking about the key drivers for the big data market. What is it that's driving the big data market? Why is it that a lot of companies are adopting to it? And why is it that they should adopt to it? Okay, so all the three reasons. First, business, technical, and financial. On business side, the data helps business in various kinds of domains. Almost every business has realized that without churning data, without storing data, without analyzing data, they cannot grow, they cannot enable innovative new business models. As well as they cannot have a competitive edge, they cannot have a better profitability, or they cannot increase the revenue. Okay, so data, or because in case of anything, you generally rely on data. As the businesses grow, they, if they don't accumulate and learn from data, then they will soon become very incompetitive. Other organizations who are able to understand the consumer, who are able to understand the vertical, they will be able to drive more revenue and profit. On the technical side, why would people want to go for this? Handling data, as the data is growing bigger, becomes more and more complex, and the many formats and many kind of structure comes into play. The traditional solutions are not able to cope up with it. On the financial side, the cost of data systems is going low, okay, as the hardware is becoming commodity hardware and software is becoming open source. All right, so this way we are able to, this way this way most of the companies are investing more and more time and the money into the big data domain. All right, all right, so these are the various key behaviors of the big data technology. Now you might say that what is so big deal about handling big data? So far, if you try to do some processing of say 1,000 records, 10,000 records, 100,000 records, or a million records, you will find that it's pretty fast, right? Then why are we cribbing about existing technologies? Okay, so before getting into that, let's understand what are the components of computing. These are the four components of the computing, starting with CPU and the memory and the disk and the network. Okay, when we talk about CPU is somebody who is just reading the instructions. The faster it reads the instruction, the faster it executes, and therefore a faster CPU is is the very important backbone of the computing, probably the most biggest backbone of the computing. Without a CPU, nothing will move. While the RAM, the memory is the one which facilitates the CPU to give the data. These RAMs are really, really fast, and most of the work which CPU does is interacting with the memory or RAM. Memory and RAM I'll be using interchangeably. So both CPU and the RAM will be using interchangeable. Sorry, CPU will be reading the data from the RAM and then doing the work on it. So in case either CPU is slower or RAM is slower, you will get a slower output, right? So the faster the RAM, faster will be the overall processing. Generally, it is the RAM which is slower, not the CPU. Therefore, RAM is the bigger bottleneck than the CPU. So, so we cannot ignore, and as a matter of fact, your computers, most of them, if you increase their RAM, they will become really, really fast. Okay. Also, increasing the size of the RAM along with its speed both improve our processing. Now, the third pillar of the computing is the disk, which we generally ignore, but it is. So as the data grows big, we cannot fit it into the RAM. RAM is a very costly and very, very precious resource. RAMs are not available beyond, say, few hundred gigabytes, right? Therefore, the data bigger than few hundred gigabytes, we put it in the disk and then read it in the RAM. Therefore, if if disks are, after some time, if we cannot accommodate the data in the disk, then we have to put it in the network. So all these four components, whether CPU, network, disk, and RAM, all of these components are important for analytics, are important for any kind of computing or storage. So in case of disk, you will be surprised. The bottleneck with respect to disk is IO, the number of bytes that we can read. We can hardly read 1 gigabyte data in 5 seconds from a disk. Now, from a normal hard drive, I'm not talking about solid state. Solid state is around 20 times faster than the normal hard disks. So coming back to what coming back to the four pillars of the computing: CPU, memory, disk, and the network. All these four components are the backbone of the computing. And when we talk about big data, at least one of them is going to be the bottleneck. At least one of them reach to a point that, hey, we cannot vertically scale our computer. Vertically scaling means we cannot increase the specification. We cannot buy a bigger hard disk or bigger RAM or bigger CPU than this, and we don't have any other solution right now instead of going to multiple systems. All right, so when we move to big data, the reason is one of these four components becomes such a big bottleneck that we cannot handle it using a single computer. All right, either the network or the disk or the memory or the CPU, at least one of these become a very big bottleneck. And that's when we move to a distributed computing. Yes, Rama, Vineet, and Karthik, you have your raised the hands. All right. So very quick questions to all of you. So let's just understand. So handling traffic of e-commerce website, out of these four, which one or which all will become the bottleneck? As the traffic, let's say you have a computer having these components, and this computer is handling the traffic of e-commerce website. What if the traffic grows bigger? What happens? What are the things which will become the bottleneck out of the four? Anybody? All right. Vinayak says all. What will be the first thing that will become bottleneck? All right, all right. Brilliant answers. Network, RAM, disk size, network, CPU. All right. Great answers. So the first thing that actually becomes the bottleneck when we handle the e-commerce website, it is the RAM. Why? Because number of connections that you open is directly proportional to how much RAM do you have. Okay, so it is the RAM that will become the first bottleneck, and that will become a no-go situation. That, hey, we cannot increase the RAM beyond 200 gigabytes, so we will have to have a load balancer to divide the traffic. Now, moving ahead, moving ahead, let's say you forgot the password and you are trying to brute force it. Brute force is in trying all the combinations of all the words of the universe. So in those cases, what is it that will become the bottleneck? You have the encrypted version and you are trying all combinations. and encrypting all combinations and comparing with the encrypted password. So which one will become the bottleneck? Pranav says CPU. That's correct. Yes. The CPU will become the bottleneck. Brilliant. All of you are getting hang of it. I'm pretty happy. All right. So, Karthik, we are not attacking some system over the network. If we had been trying the password recovery over the network, then the network could have become the bottleneck. You are right in that sense. All right. Now, let's say finding the average purchase of 10 billion customers. You have a database in which there are 10 billion record. All you want to do is find the average value of 10 billion customers. So one customer bought 2 rupees, bought with 2 rupees, second bought with 100 rupees, third bought with 1000, and you are trying to compute the average purchase. Okay, so which one out of all of these become the bad bottleneck? Billion looks like all of you are getting hang of it. It will be the disk speed actually, which will become the bottleneck. Also, it will also mean in case your data is stored in the network, not on one disk, then it will be the network which will also become the bottleneck. In case you are reading the data from the network. So these are just answers, and based on architecture or based on exact semantics, your answer might change. All right, that you will only figure out when you actually look at the hardware, look at the data size, and look at the problem you are trying to solve. All right, so let's take a break of 5 minutes, come back at 9:10, and then discuss remaining problems. Okay, so break for 5 minutes, back by 9:10 p.m. IST. All right. So let's. All right. So we were discussing various kinds of customers of big data. Is everybody back? Should we start now? All right. Great. Great. All right. Rama, Vinith, you have a question for me? You've raised your hand. All right. Now carrying on with the further discussion. So the examples of big data customers in energy, in case of vertical called energy and utilities, the seismic data processing, understanding whether seismic data could be utilized, seismic energy could be utilized or not, understanding the smart meter. For example, there is a company called Bijli and O-Power who are trying to understand, who are trying to figure out which equipment do you use based on the meter. Okay, the kind of voltage that you receive at meter. So there are many companies who are trying to help in the domain of engineering just by just by big data analysis. Okay, now second is the financial services. For understanding the risk or consumer and market risk, they have to do the modeling, and such modeling is only useful if it is done on considerable size of data. Similar is the case of personalization and recommendation. Personalization and recommendation is a classic big data problem, because the bigger the data, the better it is, and handling, and the bigger the data, complex it is. Therefore, you require a big data processing. Fraud detection and anti-money laundering is again the difficult problem and a brilliant challenge to solve using humongous data processing. So figuring out the pattern of fraud based on the past history, uh, and detecting it as early as possible is a very big challenge. And that can only be done if you have a considerable amount of data. Similar is the case of portfolio valuation. If you have humongous data, you can always plot a graph on it, prepare a relationship between various attributes of portfolio with respect to the valuation. Similarly, in case of public sector, data and application consolidation is another thing, because you require a place where they can store application and data. System intelligence and fraud detection, advanced data fusion and analytics, infrastructure and skills optimization. Those are in the public domain. Healthcare and life sciences is undisputed user of the latest computing always, starting with genome processing and DNA sequencing to drug analysis as well as the clinical quality and cost analysis. There are many use cases in case of healthcare and life sciences. Okay. All right. Yes, Rama, you have a question for me? All right. The next is media and entertainment, starting with search and recommendation optimization, user engagement and digital content analysis, along with ad and ad targeting and offer targeting. If we can target an ad correctly, it will be as good as a recommendation. So the when you are showing an ad to the user, if it is very much related to his profile or what kind of things he's looking for, then the chances of his clicking that ad is really high, and he will not feel it as spam, or he will not feel it like a noise. So sentiment analysis and social media analysis. Along with that, probably retail and e-commerce is the one who has done a great wonderful job in case of big data analytics, starting with the recommendations and starting with a 360-degree customer view. They can do a lot of things by just analyzing big data. I have been from Amazon, so I've seen the how AB analytics and understanding the consumer behavior changes the rules of game. The more you understand the consumer behavior, the better the better experience you will give, and hence the more loyalty you will have from the customer. Merchandising and supply chain analysis. Merchandising as in which product to display where so that it can increase sales. Similarly, the supply chain analysis, understanding how can you optimize your delivery services, how can you optimize your delay, and how can you optimize your um, what do you call spoiling of goods. So there are many aspects in case of retail and e-commerce where big data or any data can play the game. Just that since these verticals are huge, therefore they will have bigger data, and to process that kind of data you will require a big data tool. All right. In technology and communication, in technology, whether it's geospatial, as in geographical data analysis, image and video processing, product research and development, cybersecurity and fraud detection. Along with that, in telecommunication, if you know the behavior of the consumer, you can stop them from leaving you. You can prevent the customer from leaving you. Similarly, if you can do a product research and development quickly if you have good enough data and you can analyze that data. Similarly, you can always do the network capacity trending, as in this side of network has been increasing at this rate, and this kind of network has been increasing in this pattern. So you can predict, if you can predict that, you can also manage that. And of course, the internet of things. Okay, that's probably a common thing as of today. All right, that's a common thing as of today, as in, so what exactly do we mean by internet of things? All right, Aditya, I'll answer your question. Okay, so first is internet of things. So what do we mean by internet of things? Object, animals, or people transferring data over a network without requiring some operator's interaction. Okay, so continuously, as of today, people are gathering lot of data from all kind of devices, and that when things are connected to things, that changes the way we look at the data. Okay, for example, for a farmer, they could insert hundreds of temperature sensors in their field and observe the temperature across the fields and see how is the produce going based on the temperature. All right, so it has been tremendously successful. If you your observe your plants, you can actually improve the produce by just observing the temperature, humidity, soil condition, and others. And there are sensors for all. And the only way to observe all of them is by collecting data from all of these sensors and then doing an analysis with respect to how the temperature variance impacts the produce. Okay, so there are many use cases of internet of things. Now question is, first let's understand how does Internet of Things impact you to use the big data technologies? If you have more and more sensors across the network, there are few things which are changing. First, you are having lot of velocity of data coming in, because all of these sensors, imagine you have thousands of devices connected to the server sending requests per millisecond with their latest information. Now, your servers should be ready to be able to handle thousands of requests per second, as well as your servers should be ready to handle that amount of data storage. Okay, so and that could be only done if you have considerable amount of data coming in. That could be only done if you have a big data infrastructure in place, because big data infrastructure solve exactly that kind of problem. All right, so the applications of Internet of Things is humongous, and since Internet of Things depends on storage and the velocity that the server can handle, therefore the every implication or every application of Internet of Things would impact the usage of big data across the industries. So for example, these are the various things you could do with internet of Things. For example, in agriculture, you could gather equipment information, and can, if you are a big farmer, if there's a big farmer who is having multiple equipments to manage their fields, so they could gather the information about equipment periodically, automatically, and predict which equipment is going to break down just by collecting the vibration from the equipments. Similarly, I mean, this happens quite often in the large industries to detect the equipment breakdown. And then you if you gather the soil temperature or moisture or humidity, you can predict a better produce, or you can improve, or you can if you keep a track of moisture, you know when to water your plants correctly. Okay, so because periodically does not solve the problem, because it might rain, it may not rain. In case it rained, then you don't need to water, and all of this. To automate all of this, there are many cues you have to follow, such as moisture and prediction of the rain. So if you combine all of these information together, you can impact agriculture in a wider way. Building smart homes, buildings operate at peak performance. So if you have smart homes, then you can do a lot of things to optimize the efficiencies. Okay, so to automate a lot of things, to automate without human intervention, so those are the smart homes. Okay, the communities such as smart cities, parking space availability systems, and intelligent traffic monitoring system, intelligent highways, weather adaptive street lighting, and more. Okay, so there are many more uses of big data, Internet of Things coupled with big data in a lot of domains. Similarly, in healthcare, you have infant monitors, you have smart diapers, you have pills with ingestible sensors. So there are many more use cases in of Internet of Things in healthcare. Now, all of these are now becoming popular because hardware has become smaller, cheaper, and available everywhere and faster. So the processor, for example, the Arduino processor comes around in 15 rupees. And also the hardware has become open source. And because of hardware becoming cheaper, faster, and available everywhere, cheaper, faster, and what was the third thing? More powerful. So, along with that, cheaper, faster, and smaller. The hardware has become cheaper, faster, and smaller. Along with that, the hardware has become open source, and you can print lot of hardware as of today. You can build your own own processors given the standard specifications. So building Internet of Things has become possible now. We have been talking about Internet of Things since the Bluetooth time. But today is the time, now is the time when you can actually build things by yourself. And as a matter of fact, if you want to start building electronic gadgets, it has become really, really simple in today's time. Yes, it is being recorded, and I'll send you the presentation. Now we have a question. Let me finish a couple of more examples, then we will take up the questions. All right. The other aspects of Internet of Things is impacting every aspect of the human sciences, and every aspect of human need. Uh, and manufacturing is probably the one which is already impacted. Okay, so improving operations by putting GPS, sensor tracking, and automation like alarms, and there are many more use cases of making things intelligent. Okay, product quality and decreasing safety hazards. So these are the prime important areas where a lot of people are doing innovation in manufacturing industry, and all of this is now possible, something which is very cheap and is now possible. Similarly, in case of smartphones, you can control everything from door lock, thermostat, light bulbs, vacuum cleaner, and more. You can control everything from smartphones. In utilities, you have smart water meters which can predict the water leakages, as well as you have smart electric grids that can adjust rates upon the usages. Okay. The wearables is another domain which is coming up with every new gadget every day, starting with fitness trackers. Now fitness tracker can actually predict whether you're walking, sleeping, or deep sleeping, or awake, or doing exercise, or playing a game. So based on all of this, fitness tracker can actually gather a lot of data about your health and can help you in many ways. Smartwatches as in, they have everything in them along with all the sensors, and health monitors, heartbeat, glucose, and everything is now, it's now possible to track and measure all of these. So there are many more ways the Internet of Things is impacting the human need. And Internet of Things is not is useful only if you have a place to store and you have a data system which can analyze. So Internet of Things will produce data, you'll have to store it, you have to handle that many requests, and you have to analyze that. And that is probably the bigger challenge when it comes to handling data. Okay. While building such product is interesting, yes, Amit, don't worry about the video and the slides. Those will be available to you. All right. So recommendation is another use case. So before we move to recommendation, let me just pick up question which I have not answered. So one question is, all right, let me decrease the font. All right, I hope the font is okay now. So Aditya's question is, what are the applications of big data in space? So in case of space, I'm assuming that the space, the you're talking about the field of science where we explore the space around. So there are many use cases, and probably if you look at the NASA's website, one of my student has been from NASA. So when I looked at their problem, the problem was far more interesting, the kind of things they were trying to solve. So they gather the satellite data, they gather the data from all the stars. So in case of space and all, whether it's a aerospace or satellite system, there are many more cases of utilizing big data, because most of the problems are of humongous size, and they were the first adopters of the big data technologies. All right, is that what you meant, Aditya? Mehdi's question is it SNMP agent send data from sensor to consumer? Both. SNMP agent is the simple time agent. I think it's a time server which keeps on sending the ping. Simple network management protocol. I think that's what it meant. So it's not. mm, Although SNMP agent does send the data, but in today's time, all these devices have become intelligent. The devices, there is always a software running inside every devices. Okay, so if you look at the processors in today's time, having a small processor which can keep running the and uploading data is very much possible as of today. Okay, so it's very easy to program the agent by yourself. All right. So along with SNMP agent, because SNMP agent is somebody who runs on an operating system. So if you are having a very small device, the SNMP agent may not be there, but you can code you can code your own system such that it only sends you the data which you exactly want. All right. I hope I have answered your question, Mehdi. Yes, Sandeep, I'll provide you the recorded session after this. I'm hoping that nothing crashes it. All right, brilliant set of questions. All right, the other sample big data problems are recommendation. Recommendation is recommendation means suggesting you something based on your past behavior and other people's past behavior. So, by definition, recommendations would be better if it is done on a bigger data. If there are only three people in a room and these three people are suggesting each other their recommendations, it won't be that great. But if you have a million people around the world and you find the similar people in the crowd and you give the cross suggestions, it will be far better. Therefore, recommendations make sense only if it's a huge data. Just like average height makes sense only if you compute the average height of lot of people, right? Otherwise, it will be very skewed. The number will be very skewed. Therefore, the bigger data is far better than the bigger logic. All right, so bigger data will provide you a better recommendation. Even if you are just computing the average value, still the recommendation is going to be great, if even if you are not using a complex algorithm. Okay, so bigger data means better recommendation. Here, there are two kinds of recommendation. One is people who bought this also bought that. Second is people who you can wear this with these kind of things, and that is only possible if you have enough data. The right one is hand curated, while left one is curated based on the history of users. And this is the next step to the recommendation based on your choice. So first is your choice, second is what other people do with what other people buy with this product, and so on. So one is product to product recommendation, other is personalization or personal recommendation. So all of these are all of these are the big data problems, because the bigger the data, better they are. And if you have gathered big enough data, computing recommendation is actually difficult game. It requires huge CPU cycles, meaning you have to go through data multiple times in order to generate the recommendation. Now, but the big data systems such as Mahat, although now MLlab, have solved your life, made your life really simple. All you have to do is prepare your data in certain format, like here in 3 column format, feed it to Mahat, and Mahat will generate the recommendation. So you can feed the user ID, name of meaning a user ID. Generally, it's a number. Here I have displayed it as a text. So if you format your data in this format, this person likes this movie this much, and you prepare this 3 column data, then Mahat can generate this person what this person will like. Okay, so Mahat will easily generate the recommendation. So all I'm trying to demonstrate is that given the current state of technologies, generating recommendation, learning, or doing various kinds of predictions has become very easy if you know how to do it. It is not a rocket science as of today, just that you need to know how to do it. All right, it doesn't require too much of programming. All right. Next is the sentiment analysis, understanding the sentiment of people towards your product. So, understanding of your of, sentiment of the people towards your product involves gathering a lot of data, then gathering a lot of data and inferring whether it's a positive or negative with respect to your product. Okay, so you can gather the data from Facebook, Twitter, and lots of many places. So, and then you can also compute, you can also infer based on the keyword, based on the polarity of the keyword, based on the language, that whether people are talking positive about you or negative about you. Okay, so combine together all kinds of data sources, whether Facebook, Twitter, or Instagram, or various kinds of other networks, you could gather whether your product is going to go big, or is it having a positive influence or not. All right, so this is about sentiment analysis. Karthik's question is, what is the way to get to tomorrow's class if you have not enrolled? So our first classes are open to all. If you have not enrolled, you can enroll by paying at nobigdata.com. All right. The next question from Pranav is, does it mean more standard deviation is proportional to big data? Does it mean more standard deviation is proportional? Not really. Not really. Having bigger deviation or smaller deviation is is the nature of the data. So whether the data with data the deviation grows or not, it is a behavior of the data. There would be some circumstances in which deviation is growing lesser, while in some circumstances deviation might grow bigger, and that is the truth. So it's just that the bigger the data, you move towards truth. Okay, whether the deviation is higher or smaller, that's a bet based on the truth. Okay, in case let's say you are just picked up 10 records which are very similar in nature, and you try to compute the deviation. Standard deviation is how different are you, how much, how much the products are differing from each other. Okay, so it all depends. Okay, it's just that as the data grows bigger, you move towards the truth. Neerav's question is, are you covering Spark and Hadoop both? So in this course, we are going to cover few components from Spark, few components from Hadoop, whatever is required for big data analytics in today's time. We are going to cover, for example, we will cover MLlab, we will cover MLlab as well as we'll cover Spark R along with normal R. While in case of big data, we'll also cover a little bit about Pig and Hive. Okay, so whatever is required for analytics we will cover that, but there are other courses we have. One is for uh, one is for Hadoop development, other is for Spark development. So we will cover those in detail in those courses. In this, you won't require much of a programming language, but knowing SQL or knowing databases will be an added advantage. All right, great. So this is here we are talking about big data analytics. All right, so that was about sentiment analysis. Yes, Aditya and Rama, you have a question for me? You've raised your hand. All right. Now there are lot of advanced analytics application. Normal analytics is just trying to compute various kinds of insights into the data, like what is like what are the various verticals our customers are from, what is the average age, what is the age distribution of our customers, or what has been the productivity of various machines. Okay, so those are our traditional analytics, but traditional analytics, if coupled with big data, it can give you great result, just that it becomes difficult to do the traditional analytics on big data. Computing even the average or summation over huge data or fast moving data becomes impossible. Okay, so we will cover how to solve those kind of problems. Okay, so in advanced analytics is there are many kind of advanced analytics application. One is one of the big use case which organizations are finding is preparing a single view of customer, how to acquire new customer, grow existing relationships, and retain valuable customers. Next use case of advanced analytics application is predictive analytics, doing a forecast, then that maintain that our uh, system is going to break down at that time, so we should start doing the preventive maintenance, or doing the forecast in the sense that this route is going to be this particular route is going to be congested, so accordingly we should give the resources. Okay, or we are going to have a this kind of demand this Christmas, so we should optimize the resource accordingly. Similarly, behavioral insight. These are the 20 customer categories that is that we have to do. For example, I have been planning to work with Quicker, where they are trying to predict the behavior of the individual from their purchasing his immediate purchasing history, such as in case you are selling a lot of furniture, that means you may be moving out of the city. Okay, or in case you are looking at lot of new stuff, which means you and there are couple of more insight into the consumer behavior, based on which we are trying to predict whether a user is recently married, or is moving out of city, or has moved into the city, or is looking for is having recently has become a parent. So based on the behavior of the consumer, based on the purchase history, what kind of what kind of pages they are viewing, we are trying to bucket the user based on their behavior. All right, there are a few more questions, so we will take it after predictive analytics. So there are a few case studies, such as in oil and gas. They were able to integrate exploration with seismic image processing. Seismic as in the earth, inside the earth, whatever data we gather, building a relationship between the vibrations of earth along with the oil exploration. Meaning, okay, here maybe basically predicting where to explore the oil. Optimize lease bidding and reliable yield prediction, meaning should we bid or should we not bid for an oil well. Define and monitoring operation set point for the well. So based on the history of the place, people are able to build various kinds of operational set points in the well. Next is in the manufacturing, assure just-in-time delivery of the raw material using RFID better predictions and using better predictions. So if you have a great predictions, you will be able to optimize lot of resource crunch and control quality with real-time and historical assembly line data. Avoid stoppages with predictive, proactive, and preventive equipment management. The other few case studies are from UC Irvine, where they had 9 million semi structured records of 1.2 million patients for 22 years. So, records were made searchable. Predictive analytics to reduce readmittance as in somebody just got released from the hospital and after a day or two they were again taken to the hospital. If a hospital is able to figure out when to release people on time, then this kind of readmittance will not happen again. And real-time surveillance for rapid response. So lots of organizations are able to form that are able to utilize big data into these domains. Data discovery, okay, and exploring the data as in health insurance bought together electronic health records and handwritten claims stored as PDF. Okay, so generally the health insurer needs to crunch a lot of data. So health insurer was able to bring all the electronic health records in all kind of formats to a single place. Okay, on HDFS or Hadoop or on the big data lake. So those are the few case studies, and data discovery is a common example. These are the common myths about big data. All right. All right, there's a question from Pranav. Question is, I hope I've not. Yeah, I think I've missed a couple of questions. Yeah, right. So there's a question from Darshan. Darshan is saying, do you have a diagram showing various tools like Hive, Big Mouth, etc. in Big Data Stack? Yes, I do, but not as part of this today's session. It'll be in the second session. Okay. Another question from Pranav. Please give an example of traditional tool of analyzing data. So an example of traditional tool of analyzing data could be R, could be even your SQL is heavily used to analyze data, and even SAS is used for analyzing data. All right. Other than even MATLAB kind of tool is also used for analyzing data. Even your Excel sheet is used for analyzing data. All right. And of course, you cannot deny the whiteboard and pen and paper. Mohammad's question is big data real-time analytics? Real-time analytics is just one part of it. Okay, the part that handles the velocity, and then there is a part that handles the analytics of stagnant data, which is volume of the data. There's a question from Darshan. I would like to answer that. For quicker example, can the behavior region can be generated automatically? May not cover all the use cases manually, I guess. So behavioral can be generated automatically in lots and lots of cases. Don't you see how Gmail categorizes your emails? Right? In the similar way, it is actually possible to a very large extent. If you have good enough data. If you have small data, the predictions will be very buggy. Predictions will be based on few insights, not uniform. Now, Yashi's question is difference between recommendation and prediction. Recommendation and predictions are actually similar in nature. Okay, are actually similar in nature. If technically there is not much of a difference. Recommendation is actually a predictive analytics system. Rama's question is, do we have API to analyze PDF? Yes, there are many APIs which can extract text from PDF. And to churn the text, you have many kind of systems. What career prospect of the fresher for big data Hadoop developer in India and abroad? Okay. Fresher with a career switch, doesn't it sound opposite to each other? Okay, so my strong suggestion would be that have a good knowledge of databases, at least you have a good knowledge of SQL, or, or at least a way to churn data, as in prepare the SQL queries, is and have a little bit of knowledge about any programming language. Start with Python, that will be easier, so that if you are looking for big data Hadoop developer in India or abroad, then that will be the minimum kind of requirement. Okay, so I hope I've answered this question. Is big data real-time analytics? So not really. Real-time analytics is just one part of it. Real-time analytics means data is coming fast right away and we are predicting on it. So one of the projects which we are doing with Dell right now, it involves the processing of all the events related to order and immediately informing them, hey, this is a fraud, this is not a fraud, this you cannot deliver in time, this you can deliver in time. So that is real-time analytics. Okay. All right. So Amit's question is, MATLAB is easy to learn and use. What are the cons of using it for big data? MATLAB is single system. It doesn't scale. You cannot do things like use two computers to do some analysis. Okay, not distributed. Okay, you cannot solve a single problem using two computers using MATLAB. So Ravikant's question is scalar demand in the big data? So I would say have a look at do a comparative analysis on a website, uh, on a career website that will give you a better idea. So I don't I mean a programming language is not a big reason for anything. Scala and Java and Python might differ only a very small fraction. What is important is to understand the overall philosophy and the ecosystem and ability to utilize any programming language to solve your problem. Because whatever you can do with Python, you can do with Scala and Java as well. All right, there's some more question. Let me try to answer though. I heard even updates are possible in Big Data Hive. Does that mean do we delete the existing data and add new record? How do we achieve updates? So that's a little offbeat question from the current theme. I appreciate the question. Could you please either drop this as an email or put it in the forum, because after the session I might lose this question, so please put it on our forum. I like to answer this question, right? As we have Spark now for R, why not MATLAB? Okay, that's a very good question, Yash. Maybe people are working on it, and maybe I'll also try to see if we can change the basic library. That's a very important question. Okay, so MATLAB is kind of proprietary, so you can't touch it much. So the guy behind MATLAB is trying things. So Amit Doshi's question is parallel computing toolbox allows doing distribute? I'll say partially. There are certain parallel computing toolbox which are not yet possible to do the parallel. Okay. For example, NumPy, SciPy both allow parallel computing but are not really too much distributed. All right. The question from Pranav is R tool is traditional tool, then why it is still used in analyzing data? It is used in analyzing small data. The good part about R was that R has got a great support from all across the world, and it was great for analyzing small data. So luckily, some people realized that they could convert R programs into distributed way in the minimal effort, and that's where they devised Spark R. That's why the language has been revitalized. All right, I hope I have answered your question. So Sahib's question is, we will use Hadoop as ecosystem for this training. Not only Hadoop, we will use multiple systems. If you go through the index, there are multiple systems which we are going to use. Okay, so this course is going to be really tough, really demanding. All right. Yes is saying why Spark R has good scope in future. The reason is R has got greatest library. That library can run in Spark R, and Spark R can solve the problem using multitude of computers. The only problem with R was that it was only running in a single computer's memory. So you always needed a very big hard disk and a very big RAM to solve the problem. Now that problem is solved by distributing the work. So that's the question is, are most of the analytics algorithm created to be parallel? Will the course cover such algorithm? Yes, we will just cover what does an algorithm do. We'll not get down into the detail of an algorithm. Okay. The more details about distributed computing is covered in our Spark course. All right. So Karthik is saying how SAS is related as traditional tools with analyzing data because SAS is great with respect to people are able to analyze the data, but SAS is right now not possible on multitude of computers parallelly. I'm not sure if they are working on it, but it's more of or less SAS is proprietary. Okay, so the chances are that it won't evolve that fast as R and Spark are and other competitive tools are. Okay, so therefore these kind of tools which are proprietary will become very traditional very soon. Okay, so that's pretty much for today. We will cover rest of the solutions. We will go into what are the various uh, or we can just take 5 more minutes. All right. So these are the common myths. Most of you would be aware of these common myths related to big data. If not, just go through this list. Okay. Now, the big data solutions, there are many solutions which help you handle big data. One is having an ecosystem of Hadoop. So Hadoop provides the biggest ecosystem and support for today. It has the disk storage, it has a NoSQL, it has a churning engines. Along with that, on top of Hadoop, you can run Spark, and that is probably the best combination. The CloudX lab, which we have, and most of our computing it has performed most of the other outperformed most of the other systems just because of this combination of Hadoop and Spark. Both of them really work together pretty well. So on Hadoop, after it became Hadoop 2.0, it was possible to create lots of applications. Therefore, you have Kafka running, you have Spark running, you have you have real time as well as volume game. So both the things you are able to handle in Hadoop along with Spark and other tools. So Hadoop plus Spark provides you volume, velocity, and complexity, all three of them together. So solution for all three of them together. Now there are the solutions like Cassandra when you have to store the lot of data, say from Internet of Things only. But on Cassandra, you can write MapReduce, but there are not many libraries as there are on Hadoop and Spark. Now you have MongoDB. MongoDB, again, same story as Cassandra. MongoDB provides you a great way of storing the data in the form of documents, but for churning, you can do MapReduce or you can use their aggregation, but you cannot have that sophisticated libraries which are available in Spark and Hadoop. Okay, and in Google Compute Engine you get everything. Just the problem is that the data is located inside the premises of Google. Okay, so you will have to first transfer the data there and can do a lot of churning in Google architecture. So those are the few of the many solutions available as of today for big data analytics. All right, there are two Hadoop vendors which are which are with the Cloudera. Sorry, there are two Hadoop vendors in general, most popular out of many. One is Cloudera, other is Hortonworks. They both provide their stack in and including the Hadoop one, and most of them actually have similar tool sets. On CloudX Lab, we have taken the best components out of both the sites and put it on our Cloud Labs. All right, so we will go into the details of the ecosystem in the second session. All right, so we are 2 minutes late. All right. All right. So, yeah, lots of people have complained about voice breaking. Could you tell me from which slide should I repeat? Should I repeat from here? All right. So, let me do a recap. So, it might take 5 more minutes of your time. All right. I hope that's okay, Vineet. I did not cover the 41, 45. That's a general slide. Okay, so the 45 one is the big data myths, and these are the common myths you will get to listen. And the big data solutions I was talking about. So I was saying that if you have Cassandra, Cassandra provides you a good way to store data, and also you can do the computation on Cassandra using a SQL like language called CQL. Along with that, you can do a complex processing using MapReduce. But beyond that, nothing. It becomes pretty difficult to do the processing using Cassandra. But you can combine Cassandra and Spark together to do the computation. Similarly, if you have MongoDB, you can store a lot of data in MongoDB, but then you can combine it with Spark. Here, in case of Cassandra and Spark or MongoDB and Spark, the challenge occurs when Spark is installed in one cluster and MongoDB is running on somewhere else. So the transfer of the data might be a bit of bottleneck. Okay, so that's about this. But if you're using Hadoop ecosystem, you will be probably in the best of the uh, in the two in terms of tools. Hadoop combined with Spark provides the best of the breed solutions for your data analytics requirement, because Hadoop provides you a storage in terms of file system. Hadoop provides you storage in terms of NoSQL called HBase, and Hadoop provides you various kinds of solutions like Zookeeper and many more. We will discuss all the details. So Hadoop is probably the most complete big data solutions out of all others as of today. Hadoop combined with Spark, because Spark can run on top of Yarn. So Hadoop nowadays comes coupled with Spark. So this combination of Hadoop and Spark is probably the most complete data solution you could have. Now, Google Compute Engine, Google Compute Engine, if it is, if you are okay with sending your data to Google's data center, then that will be the good solution. But the data will be inside the premises of Google. So Yes's question is, can't Cassandra be integrated with Spark Hadoop as Spark can be? Yes, it can be. So Cassandra doesn't provide you the computing libraries. Computing libraries are provided by either systems like Mahout, Pig, or or Hive, or MLlib, or SparkR. So all of those components are part of generally Hadoop and Spark. Okay, so if you have Hadoop anyway, you wouldn't need Cassandra because you will have HBase. Okay, now Prindav's question is, will the rapid rate of increasing data every day result in limitation of cloud storage offering in the near future? Not really, not really. Because no matter what, if you are gathering data, you will be transmitting that data over the network, and that will happen continuously. So you cannot even if you yourself are gathering data, your data is coming from somewhere over the network. Now, difference between coming to you or coming to cloud storage, it will be the same thing. Okay. Now, Darshan's question is, how does machine learning fits into picture? Good question. Let me try to be crisp and quick. So, machine learning is good only if you have humongous data. Just like a person with more experience is able to cope up with more kind of situation and is able to figure out solutions more. Similarly, machine which has seen more data can plot a better graph and do the prediction better. Okay, so that's, and therefore if machine learning happens over humongous data, only then the results will make sense. If the machine learning is happening over small data, it doesn't make sense. It doesn't make any sense of running machine learning over say 10,000 data points. Machine learning makes sense only if you have 100,000 data points. Therefore, machine learning is something which requires big data, and Spark as well as Hadoop both provide a great machine learning platform. All right. The second class will be tomorrow. That's Madan's question. So, yeah, let's meet tomorrow and take the discussion forward. We are going to go deep into the architecture of Hadoop. In case you have not yet enrolled, you can enroll from here. Okay, you can enroll from here, from this website. All right, have a, so that was about the first session of big data analytics. So from tomorrow we are going to go over all the existing tools, and then we are going to deep dive. All right, okay, so thank you very much and have a great day. See you tomorrow at the same time. All right. Thank you, Darshan. Thank you, everyone. Thank you, Vineet. Thank you, Pranav. I hope the session was helpful for you. Feel free to ask the questions. Feel free to ask the questions on the forum, and I'll try my best to answer your questions. Okay. Thank you, Darshan. Thank you, Vineet. Thank you, Madan. Thank you, Yash. Thank you, Pranav. See you tomorrow. All right. If you have enrolled, you will get the link for tomorrow. Thank you, Nirbhay. Thank you, Jeevan. Thank you, Ahmed. Thank you, Nilesh. Thank you, Ravikant. Ravi Kiran. Thank you, Amit. Thank you, Sachin. Thank you, Karthik. Thank you, Anusha. Thank you, Neerav. Thank you, Vinayak. Thank you, Vanish. Thank you, Vivek. Thank you, Mohammed. And thank you, Subramaniam. Have a good day, Aisha. And have a great day, Pavan. Bye bye. All right. I hope you enjoyed the session. All right. Great. Bye bye. Thank you very much.